Solving polynomial equations using U substitution. To solve the polynomial equation x to the fourth power minus 13x squared plus 36 equals 0 using a quadratic model requires substitution. In particular, the standard quadratic model is of the form something squared minus 13 times something plus 36 equals 0. Is there an expression that we can substitute into the model that creates an equivalent equation? Why, yes. X squared. So if we put x squared squared, that becomes x to the fourth, and then we have minus 13x squared, which is how it is here, plus 36 equals 0. On the previous slide, the equation x to the fourth minus 13x squared plus 36 equals 0 was rewritten to look like a quadratic equation, like this. Now let x squared equal u and substitute to create a new equation. U squared minus 13u plus 36 equals 0. This is a quadratic equation in that u can be solved by factoring. We can factor and say u equals 4 and u equals 9. Of course, x squared equals u, so the equation can return to the variable x. X squared equals 4 or x squared equals 9. Therefore, x can be positive or negative 2 and positive or negative 3. To solve the polynomial equation ax to the fourth plus bx squared plus c equals 0 using a quadratic model requires a u substitution. In particular, the standard quadratic model is of the form a times x squared squared plus bx squared plus c equals 0. Can be rewritten using the substitution x squared equals u to become au squared plus bu plus c equals 0. Let's practice the substitution where x squared equals u. So here we would have u squared minus 5u plus 4. And here, x to the fourth would become x squared squared, so this x squared would become u minus 7x squared, which is 7u plus 10. Let's solve this equation. So first step will be to replace this x to the fourth with x squared squared minus 5 with our next x squared here plus 4. Now we substitute in u for x squared, and we get u squared minus 5u plus 4 equals 0. This is a quadratic equation in u that can be solved by factoring. U squared minus 5u plus 4 can be factored to u minus 1 times u minus 4 equals 0. Therefore, u can equal 1 and 4. So plugging x squared back in for u, we get x squared equals 1 and x squared equals 4. Therefore, x can be plus or minus 1 and plus or minus 2. Solve for x. All right, so we rewrite this to be x squared squared minus 7x squared plus 10 equals 0. Then we will plug in u squared minus 7u plus 10 equals 0. Now we can factor this. We have u and u. This is negative and that's positive, which means these are both negative. 10 is 5 times 2, and those do add up to negative 7. So u equals 5 or 2. So when we plug that back in, so x squared equals 5 and x squared equals 2. Therefore, x can be positive or negative square root of 5, and x can also be positive or negative square root of 2. Alright, so this one looks a little different. Here we have x squared plus 1 squared plus 5 equals 6x squared plus 6. The first step we'll factor out this 6, which gives us x squared plus 1 here, which is the same as what we have up here. So we'll move that to the other side, and we will now substitute in u for this expression. So when we do that, we get u squared minus 6u, remember this is both are going to be u's, plus 5 equals 0. Now we can factor. So this is negative and that's positive, which means these are both negative. 5 times 1 gives us 5, 5 plus 1 gives us 6. So 5 and 1 will work, which means that u equals 5 or 1. So now we plug back in x squared plus 1 equals 5, and x squared plus 1 equals 1. So x squared equals 4, x equals positive or negative 2. Here we have x squared equals 0, so x equals 0. So our solutions are 0, 2, and negative 2.